Hi everyone, my name is D.R. Sandeep, working as a Senior Assistant Professor of ECE Department in this Srivasi Engineering College. So in this video lecture, I want to deliver the lecture on the basic concepts of digital signal processing. So actually, before I'm going to the basic concepts of this digital signal processing, so what is the meaning of signal? And how many signals are there? Is there any classification on the signals? Is there? And what is the meaning of digital signal? So all these questions to be raised whenever you are discussing the basic concepts of digital signal processing. So first of all, I'm going to signal. Signal conveys some information. Information may be any parameter. There are so many number of signals out there. Some electrical signals are there, some mechanical signals are there, and signal may conveying some information that will be useful to the user. So the signals are basically classified into analog, and second one is digital. Even though there are so many classifications are available in these signals, the major classification, the basic classification is the signals are basically classified into analog signals and digital signals. So what is the meaning of analog signals and what is the meaning of digital signals? So I'm taking a simple sinusoidal signal. So this is time axis and this is amplitude axis. So here in this signal, the time axis parameter t will be in the continuous in nature. Continuous in nature, and amplitude axis will be also in the continuous in nature. When both the axes you can be representing, here it is continuous in nature. So this type of signal you can be called as a continuous signal or simply called as a analog signal. Now I am performing the discretization operation on this continuous analog signal. The signal it can be taken, here it is. So getting in this way, so here the time axis will be in the discrete, but however the amplitude axis still it is in the continuous. So this type of signal you can be called as a discrete time signal. So whenever the time parameter and amplitude parameter both are in continuous, you can be called as a analog signal. And whenever the time parameter we can be, the discretization operation you can be carried out via time axis, and amplitude axis still will be in the continuous manner, then the type of signal you can be called as discrete time signal. For example, I am taking the discretization along amplitude axis in this way. So discretization I am carried out, here it is, along amplitude axis. So here time axis will be in continuous manner, but amplitude axis is in the discrete manner. So this type of signals are basically called as a sample and hold outputs. or also called as the same signal you can be represented as a quantized signal in basic communication system. So this is also called as quantized signal. Quantized signal. So that is discretization can be happen in the time axis. You can be called as a discrete time signal. The discretization can be happen along this amplitude axis. You can be called as quantized signal. Now you are performing the discretization along time axis and also along this amplitude axis. We are performing the discretization operation along the time axis, along the amplitude axis also. That type of signal can be called as a digital signal. Digital signal. So discretization can be performed both in time axis and also in amplitude axis. So this is the major differences you can be observed between analog and digital signals. So based on the discretization parameter can be carried out via time axis, via amplitude axis. Okay. So initial days, there are processing the signals on the analog signals only. So there are so many drawbacks while processing these analog signals. And in the 17th century, the concepts of digital signals will be come into picture. And we are performing, so that is the digital signal concepts will be more popular nowadays. It is almost used in every application. So basically to processing these signals, you can be called as the device you can be called as a signal processing device. Signal processing device. So for the signal processing device, I am giving some input signal, I am called as a x of t, and getting also some signal y of t. So the term signal processing is that some characteristics of the signal to be varied. So some characteristics of the signal is to be varied. The characteristics may including either frequency or phase or maybe amplitude or maybe the shape also. So some characteristics of the signal is to be varied. So only the term can be called as a signal processing. So initial days, the signal processing can be operated on the analog signals. That's why the processing device I'm called as a analog signal processing device. And input I'm applying here, it is a analog signal, and output also getting will be analog signal. But the concepts of the analog signals terms will be changed towards the digital signal. Then there is a need to introduce the digital signal processing devices to perform the operations on the digital devices, digital signals. Okay, so I am discussing the basic blocks of digital signal processing system. So simple, just like as a analog signal processing device. So here also, so the major component here it is digital signal processor will be there. Applying the input here it is a digital signal and getting the output also digital signal. This is the similar to that of the previous analog signal processor. But the problem with this digital signal processor is that there are no direct physical available signals in the digital manner, not available. The digital signals are not available physically, and all the signals which are available physically must be analog signals, will be analog signals. So there is a need to convert that analog signals into digital signals. So for the purpose, I am adding an extra block previous to digital signal processor and after to digital signal processor. So getting a digital signal here, so I am interested to introduce the term ADC. So ADC will be called as a analog to digital converter, which is used to convert analog signal into the digital signal in such a way that that digital signal output is to be processed by digital signal processor. So in a similar manner, so here also the digital signal output will be applied to DAC, digital to analog converter. So that's why, so because of unavailability of digital signals in the physical manner, so there is a need to adding some extra components. So analog to digital converter and digital to analog converter. Okay. So, but the problem with this analog to digital will be, already I am discussing the concepts of analog signals and discrete time signals, and here it is a quantized signal and this is digital signal. To converting a analog signal into digital, finally digital, so first discretization can be carried out in the time axis, and also discretization can be carried out in the amplitude axis. Then I can get the digital signal. So to convert the discrete time signal from this continuous time or analog signal, the process can be called as a sampling. So by means of this sampling concept, so a continuous time or analog signal is to be converted to discrete time signal. Similarly, so this quantized output can be getting, here it is, so by means of the quantization operation. By means of the quantization operation, and also it can be called a sample and hold output. Okay, so for the purpose, so for this analog to digital conversion, so for converting the analog data into the digital, to maintain a constant output while converting analog into digital. That means sampling can be performing, but hold the data temporarily. So for the purpose, I am using sample and hold circuit for the analog to digital conversion operation. So that's why, so I am adding sample and hold circuit before analog to digital conversion operation. Okay. So along with that, so analog to digital conversion can be performed by means of sampling. So there are some problems in sampling theorem. Sampling theorem is there. So there are three types of samplings are there. First one is oversampling, and second one is perfect sampling, and third one is undersampling. So basically the sampling theorem states that the sampling frequency must be at least twice the value of the modulated signal frequency. So this is the concept of the sampling theorem. To reconstruct the original signal from its samples, so maintain the sampling frequency at least twice the value of modulated signal frequency. So in the case of oversampling, the value of fs you can be chosen will be greater than 2 FM. In the case of surface sampling, Fs must be equal to 2Fm, and under sampling, the value of Fs must be less than the value of 2Fm. So to maintain the criteria condition for the sampling theorem, so under sampling will be so drawback while performing the sampling operation. So the drawback I'm called as a aliasing. That is, one spectra will be overlapped onto the next successive spectra. So to avoid the aliasing effect while performing the sampling operation in the sample and hold for this analog to digital converter, so I'm using a low pass filter. This low pass filter will be act as a anti-aliasing filter. This low pass filter will be acted as a anti-aliasing filter, and for this low pass filter I am applying the analog signal. That analog signal will be applied to low pass filter for the purpose of anti-aliasing. The output of this low pass filter will be given to sample and hold, which is used to hold the data while converting the analog signal into the digital signal. And for this this block is used to converting analog to digital converter. The coming out digital signal will be applied to digital signal processor, and the digital signal output again given to digital to analog converter. So finally getting analog output. So definitely the analog output getting out from this DAC will be not in the smooth manner. So that's why for the purpose of smoothing, again I am applying to low pass filter. So this low pass filter will be acts as a reconstructing filter. This low pass filter will be acts as a reconstruction filter. So finally the analog signal output. So there are extra blocks will be added to digital signal processor to getting the output in the proper way. So for the purpose, digital signal processor having a drawback here, it is complexity will be more. So in the case of analog signal processor, a simple analog signal processor will be there, giving the analog signal input directly, output getting will be here, it is analog signal directly. But in the case of digital signal processing, so extra blocks will be added. That is ADC, DAC, low pass filter, sample and hold, and a reconstruction filter. So all these blocks are to be added. The major problem of this digital signal processing will be complexity will be more. So this is the basic building blocks of the digital signal processing system. Coming to the advantages. Of DSP device or DSP system. So first advantage here it is accuracy. So accurate because digital signals are more popular than the analog signals, and there are no effects of aging effects, sensitive to temperature effects. All these concepts are not encountered in this digital signal concepts. That's why in terms of accuracy concepts, so digital signal processing devices will be accurate in manner. And second one here it is cheaper. That is the analog components like a resistor, capacitor, in that way. So compared to the cost effect, so digital signal processing device also cheaper, but complex is more. That is drawback. Complexity. And third one, the major advantage here it is time sharing. So one processor is able to share more number of signals. That is, you are applying more number of signal to a single processor device. It is able to share the signals. So the mechanism will be very helpful in the case of digital signal processing. And by using this digital signal processing, your implementation of sophisticated algorithms in a easier manner. So implementation of sophisticated algorithms, so in easy way. In easy way. So these are some advantages of the digital signal processing. So come to the drawback. First one is complexity, and automatically complexity will be more. The power consumption also increases, and third one will be the problem of aliasing. So the bandwidth requirements. So the bandwidth requirements will be the problem for this DSP, because the always choosing the value of Fs must be greater than or equal to 2F. So these are the some advantages, some drawbacks of the basic DSP device, and various applications of this DSP device. So first application in the speech processing, image processing. In the image processing, so the operations like image segmentation, image enhancement, image restoration. So all those concepts will be based on the signals. So that image can be represented in terms of signals. And military applications, any unwanted signals can be captured by your radar device from the neighboring countries. Military applications. And fourth one may be seismology. Seismology is a study of earthquakes. So if there any earthquakes will be occurred, so to study for the purpose, so seismology. So the signals coming from the device, so we'll be able to capture how much that is Richter scale, how much sensitivity of the earthquake will be occurred. So all these concepts are the applications of digital signal processing. So these are the concepts of basic digital signal processing device. Thank you very much.